Hello everyone, my name is Tasi and I'm founder of Dataverse Analytics. Today we are going to focus on introduction to other programming and explanatory data analysis or EDA. So whether you are a student or data enthusiast or professionals, this video will guide you on simple and practical start with ARA and show you how you explore data effectively. Yeah. So what is R and why use it for everyday life? For example, let's take like that. Most of the time to learn a software so that you can use it in everyday life, you need to know why am I going to use this software and where can I apply that software and what is the uniqueness of that software. Simply, that is things that is really needed for us as a beginner who is going to learn a new things as first time. Simply other programming, it's like other programming language designed for statistics and data analysis. It is open source, widely used in data science and supported by the large community. You can use ARA for data cleaning, visualization, statistical modeling, and much more. Today, we are going to cover about 7 content on ARA programming, as I said, on introduction part and also explanatory data analysis. So we look at get started with ARA programming, and also we look at introduction to data cleaning, and also we look at introduction to data analysis, descriptive analysis, hypothesis testing, statistical test, and also graphical presentation. As you see, it's now the interface of ARA programming. For people who are new in ARA programming, just to have ARA programming as a first time, you need to go on internet and then search for, okay, you need to go on internet and then search for introduction to ARA programming, just like that. If I click on this and say ARA Studio download for Windows, you can click and download it. But also for me, I have ARA Studio in my machine. No need to spend a lot. You will see on another video that I uploaded previously, so that you can see how you can install or how you can download the ARA programming, or I will give you the link on description of this video so that you can see how to download ARA programming. So simply, as I said previously, this is how ARA programming looks like. For us, we are going to use ARA Markdown for people who are not familiar with that. So ARA Markdown, it's like the file that ARA has, so that you can learn a code. At the same time, also you can export it in Word document, in PDF document, whatever document that you can want, or even you can do analysis, and also you can publish on the open source that is integrated with ARA community environment. But for us, you can, as I said, you can do the data analysis, and also you do interpretation as it is. To create ARA Markdown, just you click on file, and then go on new file. After go on new file, you can choose ARA Markdown. They will ask you the name of that document. For example, I can say data analysis. If I say data analysis, I will choose HTML. It's like, to use HTML, you use HTML by recommended format for authority. As you see, this is the short description about each document that you can choose, whether you will use Markdown by HTML, PDF, Word document, something like that. You will choose whatever type of document you really want to export your analysis or your something that you can made within ARA Markdown. After choosing that, you will click OK. Automatically, ARA Markdown, it will open. By default, you will have things like that title. It's like that title I type by default or when I'm creating R Markdown. But here you can change the title as this. Maybe you can change to the data analysis and then you put your name. This is the author who is the owner of this document. By default you can change it, the date of creating that file, of course, and then the output, it's like HTML document, or you can put Word document, you can put Word document, or you can put PDF document. It depends. At the end of the day, if you run this R Markdown, the output of that document, you will see that document. If you run clean this document, you will see either in Word document or HTML or PDF as you mentioned. This is how it looks like. And also they will give you things like that. This is what we call chunk. A chunk is where we type our code. It's where we type our script in a chunk. And then you see this is by default, they show you a lot of things about the chunk, but also you can see here you can do interpretation, you can copy, link and paste whatever things that you want. But to make to take other markdown or other programming that you form a head or subheading, something like that, for other markdown we will use hashtag like that. If I put one hashtag, it means that what it's heading 1. If I put hashtag 2 hashtag, it's like heading 2. 3 hashtag, it's like subheading, something like that. If you increase the number of hashtag, it means that you are dividing your title into subheading until you succeed to the way you want. And then here you can write whatever you want. As you see, this is how it's like how ARA help us to see how you can use ARA Markdown. By default they give us like the document which can show us where we can type. For this part, if I'm not in a chunk, as I said, the chunk is where we can type our code. If I'm not in a chunk, I can type something, and then if I run, there is no problem, which means that I can put the code here or a script here in a chunk, and then I can run. If I click here, it's like to run the current chunk where I'm operating. If I run at the same time, I will put interpretation here that can explain the result that I'm getting above. You see how ARA Markdown is really important for us. It means that I can do analysis and above, and then on below I can do interpretation. This analysis, it means the load, something like that. You know how things should be work. And then as I said, where here you can type, and this is another chunk. It is the prod. It's like an example of how ARA Markdown should be formulated. But let's come back on our lesson of today. I think you get a little introduction on ARA Markdown. And here another thing that I forget to say about ARA Markdown, if you need to add a chunk is where we can type our script, our code, so that we can learn a specific analysis that we want. So for us to get another chunk, I can click enter and then put a space where I want to put a chunk, and then I will go on this part. You see this part, insert the new code chunk. If I click on this, you ask me if it is a chunk for ARA or if it is a chunk for Python. For me, I want to use a chunk for ARA. If I click on this, you see how chunk looks like. For here, I can write whatever command that I want. Like let's run the package code tidyverse, and then you will see how it looks like. If I run tidyverse, you see, if I run tidyverse, to run this, I can click on this. If I run, you see that now it's now working. This is how chunk works in ARA Markdown. But let's come back to our session of today. Yeah, our session of today, as I said, will be focused on introduction. We'll get to start with ARA programming, but also on the context of ARA Markdown, because we are going to use ARA Markdown until we go on advanced ARA programming, advanced data analysis with ARA programming, we will use ARA Markdown. That's why we make like a short introduction on how we can use ARA Markdown, something like that, to get familiar with that. And then, as I said, this document provides the beginner-friendly walkthrough on essential ARA programming concept, including variable, vector, matrix, data frame, and data manipulation using tidyverse packages, so that we can make sure that you know beginner-friendly basic before we jump to data manipulation, data cleaning, statistical analysis. I would like to focus on those basic operations in ARA programming so that you can make sure that you know what you are going to do. And then, as I said, here you can type whatever you want, and at the end of the day, this is a chunk. It's like if I said chunk, it's on this part you see here on these two quotations. If I put ARA and setup and then include false, it means that if I'm going to run a chunk, the warning message, I mute the warning message. If I put false, it means that the warning message should appear. But if I put true, it means that the warning message, if I run like a certain packages, there is a warning message that a package can give you by default. But if you put true, it means that you mute that warning message. But also here, let's come back to our part of today, to using ARA as a calculator or understanding data type. For us in ARA, we can start by basic arithmetic. Basic arithmetic, as I said, arithmetic addition, you can add certain variables. You can create a variable within a chunk, like a equal to 2 plus 4, and then if I print a, I will get the result. If I run this, then I can learn here, let's say run selected line. If I click run selected line, you will see that I will get 6. But here also I can learn this. This is like multiplication. This part, it means like it's like multiplication, because when we need to make multiplication in other programming, we will use single star. But also if we need to perform power like 2 power 2, we'll use double star. This is multiplication. But also the subtraction, you will use minus as it is, and you see that for addition you will use plus as it is. But if I run this, I can go on run, and then I run selected line. If I run, you see that I have 2000. But also here you can use this apostrophe, or I can use double star, as I said, and then you will see that as a power. Also it can work. It's up to you. It's up for us to choose one way you really want, you see. And then here it's how you can create and view the variable. From that, I can create variable by using letter code C. This letter stands for concatenate. It means that I want to create a variable that is assigned with a lot of things. But also to assign the combination of many values, we will use concatenate, so that concatenate helps us to combine a certain values to assign with a single variable. It means that the variables, it helps us to represent a certain values, a certain set of values. But also in R, to combine those set of certain values, we will use, say, letter C, either for numerical data or categorical data or whatever types of data, to create new or to assign the values to the variables. We will use letter C as a concatenate. As I said, this letter C means this here you can see that I can type this letter C because I'm not in a chunk. This letter C means concatenate, and I can use it for combining many values. I can use it in combining many values in single variables, in variables. I hope you understand how things looks like. And then this is how you can create numerical vector. If I run, this is the numerical vector. If I run this, we see, if I run this is how it looks like. But also I can create a character. To create character in R programming, to tell R programming that you are going to create character, you will need to make double quotation for every single values that you are going to assign to the certain variables that are character. So you need to put it in double quotation so that you can tell R that you are doing this, but also remember that I'm formulating as a character. That is only difference between character and the numerical data. For numerical data, you see that we type numbers and then put comma, another numbers and then put comma, something like that. But also for categorical, we need to make double quotation, as I said. Here we will see how we can, if I run this, okay, you see something like that. But also here you can work with working with directory or environment to check for working directory, to know the number of variables that you are already created in your data frame. For example, if I'm interested to check for working directory, I can do get working directory. If I run this, if I select this and then do get working directory, you will see that I'm working with desktop in folder which is called project. But also this RS, it's like to list for created variables. I already create a lot of variables, but I need to know the name of that created variables I already created. That variables, it means that that variables, it's now in my environment part. You see where we have environment part here. If I create a certain variables, each variables I will see in environment. Before I delete it, I will go on environment and then I will see it in environment. But also if I delete it, you see here this part of deleting. If I click here to clean object, it means that all variables that I already create, there is no longer in my memory, in the memory of my other programming. If I clean, it means that I clean everything. But also if I didn't clean and then I run this code, they will show me all the list of variables that I already create. So let's run this and then we'll see how it works. Yeah, you see that we have A, B, C and name as a list of variables that we are already create. And here it's like to set working directory. So I'm interested to set working directory. Just to set working directory, we can type set wd and then we go on the file explorer to copy the direction of folder where I'm want to shift from. For example, I'm in a project, but I want to shift from project folder and go on the desktop folder, for example, by default. So I can go on File Explorer because I want to go on other programming material. For example, it's where I want to operate or I want to continue to save my stuffs. While I'm saving, automatically I will see everything. If I run something within R, automatically by default it will be saved on that directory where I directed, where I set the directory that I'm going to set. So it means that everything that I need to save in about my project that I'm working with, unless I didn't change the directory of where I can save, they will save on that directory by default. But also to get it, I can click on this above. If I click on this, I will see the direction or the location of my folder, and then I copy it, Control C, and then I will come back on other programming, on other, and then because I want to set working directory, I will remove this. remove this and then paste this, but I have to put in double quotation. If I put in double quotation, you see, if I put in double quotation, so I need to change this backslash to the another side, or I can make it as double so that other programming understand that I need to use things like that. So it does not work with single backslash. Instead of using single backslash, I will use double backslash. If I use double backslash or something backslash, sorry, double backslash, okay, double, if I put double backslash, if I put double backslash, you will see if I run this, it's like to change working directory. If I select this and then I run, if I select this and then I run, you will see that warning message. I don't know the warning message. Okay, but the code is now working. But don't worry, the code, it is now working. Yes, the code is now working. But also if I check working directory again, if I check working directory, set wd to check working directory, set wd. If I run working directory, because I'm operating on other document something, if I run this code again, you will see that error in set working directory. I don't know the problem. Directory is missing with by default. Okay, let's see how we can fix it. Okay, let's see how we can fix it. Maybe uh, let's move to this folder and then I will repeat it again to move on this folder. I can go on, then I will do this and then I will put set working directory. I will put this. Instead, let's put the opposite direction of backslash, opposite direction of backslash, and then we see how it will works. Opposite direction of backslash. If I run this code, okay, you see set working directory. Yes, okay. I didn't change this, sorry for that. Didn't change this, but if I run this again, I see that it's now working. But if I set check working directory again, you will see that I'm changing to some dissertation. See that I'm changing to some dissertation. So get, sorry, not get, it's like get working directory, get wd, not set working, get wd to check the current working directory. We'll use get working directory, get wd. If I run this, you see now I'm changing to that. So here, if I run this, let's run set working directory, and then we will see. If I run set working directory, if I run this, warning, the directory was not changed. Okay, instead of not chunk, the working directory will be reset when chunk is finished to run. So it is currently now running. So let's change this and then we'll see. Let's change this. Sorry. Yes, okay. Okay, you see it's now working. We need to put a double backslash to test data that you can understand single backslash. Instead of using single, we use double to represent it as it is. So from that, we can go on how we can print output in other programming, but also we can see that how to print the output in other programming. So we can use print, for example here, printing output. Instead of that, I can generate the variables like a, and then I can learn. If I learn, I will get the output. But also I can create I can print the values without defining the variables, simply as that. This is the categorical variables or character values that I want to print without assigning to the variables. Without assigning values to the variables, I can generate my own variables just in simple way. Here, if I run this, I will see, I'm sure that I will see all output. If I run this chunk, you will see that because I already ran A as previous variables that I generated before, you see, but also on this part, you will see that I will get print my name and also print something like that. And to see the built-in dataset and use help command in our programming. Here to see this is to see the list of built-in dataset. What does it mean? So it means that, as I said, our programmings are on open source, but also if it is an open source, someone can generate things which is called package. For example, I can sit and then generate package for machine learning or package for actuarial model, but also to make sure that the package is working, I need to generate the dataset as a sample dataset or dummy dataset. Someone can refer to run how we can learn a certain model that I generate based on that package. And then if you have a lot of packages in other programming, it means that each packages, they have the variables, they have the dataset that can use for performing a specific task that packages is designed for. If I have packages for data cleaning, it means that within that packages there is a lot of dataset or a certain number of dataset that is there by using it to run how to use that packages I already developed. Simply as that. Means that when you have more packages in other programming, there is a default packages that you are having as a guarantee if you download other markdown from the open source, or sorry, if you download other programming or other studio from open source. But also there is another packages we need to install ourselves depending on the analysis that we are going to do. It means that if I install many packages, it means that I will get many dataset within my other programming. So to check the current dataset that I have in other programming or within other programming, I will learn this code. I will see all list of dataset that I have. If I run this, you see that there is other dataset. The dataset are in a package called the dataset. So this is a list of all dataset. This is the name of dataset and also their description. Each dataset has a simple description that can guide you. For example, if I'm interested to run survival model, I will check for that description so that I can see the dataset can fit to the task of survival model. And then let's come back on our part. But by default, I can see that this is we have within that built-in dataset, you see that we can have one of that dataset which is called carbon dioxide. I can interested to use it, or I can interested to see how it looks like. just in terms of viewing, like knows the variables, knows the name, how it is designed for example. So to open that data set, I will use view. If I use view command and then I put the name of that data set, if I do this, if I run this, I will see all variables. Yeah, I will see all data set. Sorry for that. I will see how my data set, the way it looks like, just by using a command which is called view, or code which is called view. And then from that we can use a help command for checking weight dataset. I'm interested to know the short description about the dataset which is called check weight, but I need to understand. We use help command or help code to understand more deeply about the dataset, or about the variables, sorry, about the code, about the script, something like that. If I'm interested to understand more, like knowing little information, like this data set, I'm interested to know the meaning, like who designed this data set, their purpose they have. I will use help command, code, sorry, not command. If I run this, automatically you will see the change weight versus edge of cheek on the difference died. This is a short description, and then you will continue to read until you succeed. And this is the open source, this is the reference where we go and search further information about this dataset. The help command, it means that they will help us to get more description about the certain variables. And for example, I can put carbon dioxide, you can put another dataset that you choose during the analysis that is built in R programming. This is a special case for the dataset that is built in R programming. But if we import our dataset, because the R programming, we will not know where you get your data comes from. They will not give you the description. They work, this code, they work for the dataset that is built in R programming. So other than that, you don't do analysis without you having the description of your own dataset. If it is a dataset that you are going to import from outside, so it means that you will have the description of that variables. So I think you understand this. This is how you can install and load the packages. To check the install the packages, we will use install.packages. If I run this, we will see this is the code that we can use to check for the direction or the location of the installed dataset. If I run this code, I will see the list of all packages that I have in my R, but also I'm interested to know the folder, like location. Each folder, each package is where it is located. I will run this code, but no need to run it. I think that you know. And then we will see how you can install and load useful libraries. This is how we can install new packages. I type install.packages and then I put double quotation, put the name of packages that I'm going to install. And from that, because I already have the packages which is called tidyverse in my R, there is no need to insert it again. If I have it, the only way I can there is no need to install it again, but also I can update it. Instead of install it again, I can update it, because the reason why we can update it, maybe because, as I said, the other programming is like the open source. Someone can go on the packages and then update something. Means that we update something so that it can be more easier to use it. If someone can update something, if I update, it means that that code that they insert on that packages, they will work for me if I'm interested to use it. The reason why we need the updated version, it means that it simplifies our work. And one of the important things mainly we use packages. Packages, it simplify the work. We can use simple code instead of coding all a lot. I will use that packages because the programmers, they program in a way that packages minimize the code that I can type. If I use one of that package, for example, if I'm use the packages for data cleaning, I'm sure that they can simplify the longevity of the code that I can type without using that packages. Yeah. And this is how we can road. It's like to tell other that now we are very lucky that we are going to use these packages called the tidyverse, and then give us authority, give us a permission to use it. We will use library and then type the name of that packages that you're interested to use it. This is another way of installing packages, and also at the same time to tell other that now you are going to use it. The same as here, the foreign, it's like where I know foreign, you can use foreign for loading dataset like stata, a file that has extension of stata SPSS. You can use foreign to load dataset, but not only for that. There is a lot, the lot of load that you can use the foreign. Read Excel, you can use it for loading the Excel file within the R. And here, this is how working with logical and the character vector. When we say vector, it's like one-dimensional variables. Let's say it's something like that, one-dimensional variables that we can use to represent a certain numbers or certain values, maybe character or numeric or logical, something like that. And there is, it has similar way as a variable. Yeah, as I say. As I say, it has similar way as a variable, and as I mentioned, okay. And then let's proceed on the part of creating vector, handling logical operations. This is the same to know this is how you can create the variables or vector. Variables can be a vector also. This, when I run this, we'll see how. This is called class. I forget to document it, but also this code class. Let's document here by using hashtag class used for checking data type. If I want to check data type in the data, I will use class command. If I run class and then put the variable name, they will tell me that this is a numeric. You know how to work. The same as this. If I run this, the logical data type, it is in a way of true and false. If I run this in error, they tell me that is a logical. Let's run this and then we will see. Yeah, and then you see that it is logical. The another thing which is important is to know how to handle missing value, to check missing value within the data set. A missing value, I think you know the missing value, what it means. To check the missing value, I generate the variable which is called have underscore attaché, and then I generate in other programming the missing value also can be represented as NA, non-values. So to check for missing value, the reason why I put NA, it was like to show you how you can know if you have a missing value. So in the dataset, if there is a missing value, by default, they put NA. Missing value, it's like observation. which is not answered. Let's say that during the data correction or the data processing, something like that, the respondent, if they didn't want to respond to that question. So for us, we say that there is a missing value. And then in R, the missing value, they take it as NA. And then I generate the variables and I call it have underscore Tassier. And then if I run this, this is the same way. If I run this, it is now working. But if I need to know the values that I assign on that variables, you will see. If I really want to see, I will do this, or I can do print the same. Always it can work. You will see that I have values Tassier, NA, GAN, something. And then to check the missing value, this is the code for checking missing value. It's like to check missing value, I will use is.na, is.missing, none value, is.na, and then open bracket, and then put the name of that variables. So from that, I will run this. If I run this like that, if I run this, we will see that I will have false, true, something like that. If I say is.na, they will go on my variables or with my dataset that I generate, and then they will check each value per each value. If they see that there is missing value, they put true. But if they see that there is not missing value, they will put false. That's why we have false, true, something like that. But we can count the missing value. The only way, we don't need to know where we have a missing value, but also we are interested to know how many missing values that I have in my variables, that I have in my data set, respectively to the certain variables, for example. And you know that as a data analyst, to handle the missing value, we handle missing value for specific variables, not for entire data set. We handle missing values for each or for specific variables that we are interested to look for. So that's why we need to count the missing value with specific variables, and then we will see the percentage of that missing value, so that we can, based on that, to maybe to take decision if we are going to replace the missing value on the certain ways or certain techniques that we use by handling a missing value. So to count the missing value, we use sum, open bracket, is.na, the name of variable, and then we close by double quotation, double bracket, because we open single parentheses for the function of sum, and then we will close another for the function of is.na. If we count, we will see, I guess we will see two as a number of missing value, because we have only three, we will see three, because we have true here and true here. If we run this, see that we will see three missing value. Again, also here, you can know how we can remove that missing value. Then let's have the variable which is called the A. A is equal to the variable that I generate previously that contains the missing value. It's like renaming, another way of renaming. It's another way of renaming. From here, I generate a new variable which is called the A, that is representing the variable that I generate previously, which is called Tassier underscore have. Tassier, sorry. Then to remove the missing value, I need to put exclamation mark. I put the variables that I generate, or the variables that has that missing value, that I'm interested to remove that missing value, within that variables that I'm interested to remove that missing, and then I put square bracket. I started by exclamation mark, type is .na, and then I open variables, and then I open parentheses, put that variables, and then I cross. This is how we can remove missing value by default. Can remove, it's like to delete. If I say this remove, it's like deleting the row that containing the missing value. If I run, we see that it is now deleting automatically. We didn't have that NA, but here, so we can replace the missing value with a certain number. For me, I say that I'm going to replace the missing value with 0, and also you can also replace the missing value by mean, mode, median, or another way that you will see how you can handle the missing value. But also it can work. It depends on the way you want to replace the missing value. Maybe I can say that there is no longer needed. Maybe I can delete it, or I can replace it by the techniques of handling missing value. You know that we have a lot of techniques that we can use by handling missing value due to the certain analysis that I'm interested to perform. So if I run this, and then let's run this, let's print this, print A again. Now you will see that where I have missing value, I will have the zeros. Replace A by 1, replacing only first index. This is how you can replace the specific values. If we say the index, it's like allocation of the values. For example, to make it easier to understand the index, what it is means, I can have a list of students, and then number 1 on the list, it's like index 1. Number 2 on the list, it's like index 2, until to the last. And then here, so we are interested to replace on the variable A, the first index, the first values as on the index 1 by 0. So let's run this code, and then we will see how it works. See how it works, because currently we on the previous variables called the A, on the first index, on the first line, or the first list, like number 1 as a person, we were having Tasia, and then after replacing the index 1 with 0, the updated variables, we see that now it is 0. This is how we can use something like that. We will use this in case you know where the missing value is located, and later you can say that I'm sure that on the location of on index 45, I'm sure that is where I have missing value. By default, I will say that let's replace that missing value that you normally knows where it is located on the index, and then we replace it to the value you want, something like that. So the vector also in other programming is one-dimensional correction of values of same type. It means that vector, only difference between the variables and vector, variables can have more than one data type, either numeric or the character or false at the same time. But also if we come back to the vector, it means that we cannot have vector having more than one data type. If we say that we are going to generate variables which is numeric, it's numeric for only that variables which has only one data type, it's what we call vector. And the variables that has more than one data type, we cannot call it as a vector, as I think this is clear. Yeah. something like that. And then you are creating, if you create vector, we use the letter C, as I said, the same as a variable, which is called concatenate. And this is the way you can create the vector. So we generate the vector as a numeric, as you see, called salary, and here we can take salary and then multiply each salary by salary 1, and then we multiply it by 5, so that we can see we can perform all operations that we want as addition or multiplication to the certain vectors we generate. You know, it's totally different to the variables, because variables, I can generate variables which is numeric and a character at the same time. I will no longer multiplying, I no longer applying those operations, since that variables has a different data type. But also for vector, it can work depend on the data type that you are going to use. And here I can check maximum, also I can check maximum salary, I can check mean average salary. This code, if I do this, it's like for maximum salary. It's like for maximum salary. To check maximum value, I will use max and then put the variable name. I can do this. If I run this, we will see that the maximum is 25,000, sorry. And then I can do the average salary. I can use mean, then put average salary, and then I can generate another variables, another vector, which is character vector. Then I can do character vector, and then from that to check the data type, we see that we will use class. If I use class and then put the name of variables, if I run this, if I select this and then I run, I guess we will see that this variable, it is character. And then from that we will calculate the standard deviation of the current variables that we generate, which is called salary 1. If we run this, we see that we will have the standard deviation. So you see on the environment part, every variables that I generate as a new, I will see all list of that variables, everything that I perform that needs to be in a memory of R, I will see it on environment part. And then another thing which is important, it's like matrix. A matrix is like a combination of vector. We cannot have matrix which has a different data type, as you know, because it's made by the vector, and we know that the vector is for only one data type. If we combine the vector that has the same data type, which means that we are generating a matrix. Either we can call it square matrix. We say square matrix because the row and the column is equal, or we can have a matrix which is not square matrix. The row and the column is totally different, but if the row and column is equal, we will have a square matrix. Let's look at how we can create the matrix. We start by creating the numerical vector, because we see that the matrix are like a combination of a vector. We see how. Then I generate it. There is a two-way or three way of generating a matrix. The one way, it's like by using cbind. It's like combining the vectors by using column-wise matrix. And also the another way, it's like generating matrix by using other bind, row bind matrix. Let's see the difference. So if we run this by cbind, column bind, see how it looks like. You see, we have C1, C2, C3, and then this is a column bind. C1, C2, 3, just in vertical line. But if we do row wise, it's like a horizontal line. It's like horizontal line. Let's run this horizontally. R bind. See the matrix. Let's run this matrix that we generate row wise. matrix by row way. If we run matrix by row way, see it's like horizontally, row wise, horizontally, yeah. And then the factor, what we call factor, it's more important for us. If you do categorical analysis, maybe you need to, or you may have like a data set. Within the data set we have a male and a female, for example, as one variable I take as a gender, but you need to replace the variable, you need to replace the values like female as 1 and the male as 2 due to the analysis that you are going to use. Mostly we will do that kind of things when it comes to the modeling techniques like logistic regression, probit model, because those are the statistical method we apply for categorical analysis so that we can model it. So that's why we need the factor. It's like a representation of numerical values comes from categorical variables. So we use fact when we need to represent categorical variables as numeric. Just in R, we take it as a fact. So that's why we started by generating the variable which is called gender, and then we assign as a male and female, and then we make it as a fact, of course, so that we can tell R to allow us to transform male as a 1 or female as a 2, to put it as a numeric, to put it in numeric to the way we want, something like that. This is something interesting. I need to understand that kind of thing, because you are not able to do categorical analysis in R programming without understanding the logic behind of facts. It's like encoding. Those who are knows Stata, when we need to change the categorical variables into numeric, first we need to encode it to tell Stata that this variable, it is in a way of changing that categories into numeric due to the analysis. It's like the way encode works in Stata, of course. But here also, so let's run this and then you will see. Yes, you see that after making as a factor, they will tell me that your variable, which is called the gender, it has 2 levels, male and female. One level is male and another level is female. Whatever categories that you may have, maybe you can have education level. Within education level, after making it as a fact, you will have a list of levels like education as a primary, secondary. Those are the levels that we are talking about. And then from that, if I assign, after making gender as a label, I will assign that levels. I will assign that levels as a 1, 2, 3, something like that. If I run this, let's see how it works. We see that the levels male and female, but also here I can generate another variables which is numeric, gender numeric, so that I can assign the numbers to that levels I already generate as a 1 for male and 2 for female, for example. So let's see how it will works. This is how it works. When I run the gender as again to check the numerical factor, if I run this numerical fact, let's run this numerical fact and then we will see how this numerical fact what it looks like. You will see that now it is in 1 and 2, it is in level of 1 and 2. I can do rename to check if the variable, to check if it is a fact. We will use is.fact to check if the variable is fact. If it is fact, it means that it is now okay to be transformed either from numeric to categorical, either from categorical to the numeric. It's like an authorization of changing a certain data type. So I want to change this data type from where it is to the next thing. So we need to make it as a fact, so that it's like making the variable to giving a variable flexibility to change from one data type to the another data type, as I said. But mostly in the case of categorical analysis, we made it because we want categorical to change it into numeric. But also you can have, there is no, this is not popular to change the numeric into categorical. That's why I say that mostly for categorical analysis, it's where we need to make it a fact as a first, and then we can transform it into numeric due to the analysis that we want to make. So let's run this, and then we see. You see that it is true. They tell me that this is dot fact because I make it in terms of levels. I make it as a fact. They tell me that it is true. Converting facts, see, as dot fact, we need to convert this as dot fact. This is a code we use to convert a variable as a fact, and then we want to convert as dot fact. We do as dot fact. If I run as dot fact, we see something like that. And then as dot fact, I have the variable which is called fact, and then as I generate as dot fact, and after that I will replace the 1 as male and 2 as female. Automatically, if I run this code, I generate the gender fact as 1 2 1 2 1, something like that. And then I want to do label define, label values, 1 as male, 2 as a female. If I run this, 1 as male and 2 as a female, if I run this, we'll see that it will automatically change. This is how we can change the levels. So before we proceed, I would like to know if those things that I was talking are clear now. We have run from the starting, the history of R programming, like operations that we can learn, the difference between variables and a vector. We will know how we can perform the operations like addition, subtraction on the vector, and also we will know how to generate a vector in other programming, and you can perform the certain task you want. Either you can add the matrix in other programming, either you can multiply matrix. Only way it's like the logic you have behind. You know that we cannot multiply the matrix without the matrix that has the difference dimension. We make sure that it has the dimension, which is okay, and then we know how we can calculate a summary statistic on the certain vector, like a mean, mode, standard deviation, variance, something like that. And now we are going to look at summary statistics by grouping. I can create summary statistics on income based on gender, for example. Let's see how it works, and then we see. Yes, you can find like summary statistics by grouping. Maybe I can want, as I said, to see the income by gender, something like that, by grouping based on the category levels. Here we generate the variable which is called income, simply as that. If I select this and then I learn, for example, if I select this and then I learn, if I learn this, you see that I generate the variables which is called income. So I want sum of gender, sum of income based on gender categories. So the only way or any code that we can use, so we will use tapply. Tapply, it's a code that can help us to get summary statistic, for example sum, by grouping a certain variables. Maybe I want gender I want summary, sorry, I want the sum of income for male and female separately. So let's run the code. I will put, this is the variable that I generate. As you know, you know how to generate the variables. And one of the things that I forget to say, if we generate the variables in other programming, we are not allowed to put the space among the variables. For example, I can say that sum space gender space fact. It is not working in other programming. So instead of putting space, you can use underscore. And then there is those operations like additions, subtraction, something like that. You cannot including in variable generation. It is not working for R. So we need to remove that operations, and also we are not allowed to put the space within the variables that we generate. So when we run this code, we use apply income and gender facts, because you know that we generate the gender facts as above as male and female. So let's run this and then we see the result to make it clear. So if I run some sorry, if I run C, have male and the female as a total, the same as this. To apply for gender, I need to know the only what I want. I put the name of variables that I'm interested to look for. I am interested to look for income and also to look for gender at the same time. But what I need as a summary statistic, I put the comma, because here at the first time I was interested to see the sum for male and female separately, but here I need to check for mean. This is only different. If I need, I will put the variable name, but I need to put the summary statistics, the measures that I'm interested to look for. If I need sum, if I need mean, if I need standard deviation, whatever that I need, see how it works. This is only different. This will be applied on the large data set also. If you really need to find something, you will apply it either for the large data set. And I think you know how it can work. And now here, if I do this, because I'm interested to see for standard deviation within each category. So if I run this, if I select this and then I run, I'm sure that I will see the values on standard deviation. So but here you see, if I run all of this, if I run again all of this, I will see the result. If I run this, I will see the result. So see how result it is now. Now it's okay. So I may need to clean this result because we no longer see the below one. So to make it simple, maybe I can clean here. If I click on this, you see this button, it's like to clean everything here, and then I will run again so that I can see it very well. So this is also the result, as you see. And this another thing that is interested, it's like data frame operation. So when we say the data frame, it's like the data set. It's like a data set. So to say the data frame in other programming, if we have the data set, for example, for this data, we can say the data set. So when we import the data in other programming, there is no longer a file. If it is a file of Excel, there is no longer a data set if it comes from the data. So for us in R, we say that it is the data frame. Just like the way we call it dataset in Stata, the way we call it file in Excel, when it comes to the other programming, we say the data frame, but only the name are a difference, but also the way it looks like it is the same. simply as that. So here we are going to generate our own data frame. To generate our own data frame, just in terms of row and column, to make it as data frame, it is a difference from the matrix, because we have seen that the matrix, it is made by only one data type, but also in dataset we can have more than one data type. That's what we call the data frame. To formulate the data frame or the data set in R, we call it the data frame. So that's why I'm interested to show you how you can generate the data frame here. So for example, we generate this variable which is called a region, and then we call it as factor. Let's run, and then we generate the matrix as made by income, gender, and region. So to generate the data frame, the code that we need to generate the data frame, so we need to use data frame as I mentioned. So we will use date.frame, and then we put one variables that we want. We need to generate our own data set, or what we call the data frame in other programming, that made by the variable which is called income, gender, facts, and also region. So if I run this, see how it will look like. You see, because I need to clean this so that I can see where, if I run this current line, okay, I don't know the problem. Run. So I need, you see, now it is working. The reason why I didn't see here, this side it's somehow small, but you see that I have the dataset income, gender, fact, and also region. This is how we can generate our own dataset in our programming. So, and then here you can select the one variables within the dataset. Here we want to select the region in our dataset that we create, which is called matrices. So if I run this, I'm sure that I select only region. You see, I select only region. I select only region. See the result. This is the result. The region that is Kigali, Lulindo, Gisagara, Kamonyi, something like that. Yeah, and then from that I can specify the certain amount, certain values within the dataset. For example, here I need the income which is greater than or equal. This is what we call subsetting. We need to select the values, the certain part of values, specific certain part of values within the dataset. I can use subset, and then I open bracket, put the name of dataset, comma, the variables that I'm interested to look for, and then I put the condition. Then I cross the bracket. So if I run this, I will select the people, or for example, income which is greater than or equal 666. So let's run this, and then we will see now how it's working. Everything that I run here, it's like above 666. So, and then here we can add the column in dataset. Maybe from outside we can add another column from the dataset. Here I can generate another variable which is called have job. We ask ourselves if the employee, for example, has a job I already generated, but also to add in dataset, I will put cbind. I will use cbind or other bind, depend on the way that I want to be appear on my dataset. For us, we need to put it as a column ways vertically as this. We line vertical. So that's why we know we use cbind, and then we put the name of original data set or original data frame, and then put comma, we put the new variable that we are going to add. If I can have another variable, I can put the comma and then put the name of that variable, but it's okay, it's working. But for us, let's add this variable. So let's run this. If I run this, I will automatically have updated variables, updated data set that has this one. You see, has job. Now it is added on my data set. So from here, I think some basics about creating our own data frame or our own data set within our programming, and know how you can add the variables on the existing data set. You know how you can select the specific values within the data set, select the variables within the data set. Something I think you know how you can do it. And then from that, we are going to run like how we can import the data. How we can import the data comes from the outside the other programming. So the only way, it's like we started by reading the data set that has extension of Excel mostly. As I mentioned, we need to know the libraries that is stand for that data set that we need to load in our programming. Either if I'm interested to run the package, so if I'm interested to run the file, or that is Excel or Stata, something like that. So I need to look at packages for each. So to do this, we start by running library, like to see read Excel, and only thing which is important for other programming, everything that I'm going to use, it has their own description. See here. So I want to use read Excel, but also I don't know if it is right for the operation that I'm going to perform. I may put the cursor here and then I read. This formation tell me that import Excel file into R support by this, something like that. It means that every code here in R programming, it has the short description that tells you the certain thing, the certain thing that you can do for that code. Let's say something like that. So it is totally different from other softwares like programming softwares. It is only for R. They direct you. If you are going to use the code, they give you like a short description. You can use this and this. This can be better for this, so that you can see that code that you are typing, if it is matched to the things that you want to perform. And because I need to import the Excel file that has extension of .xls, I will click on this, and then I run to tell R that I want to perform the task that is related to that package. If I run this, it's okay. And then to run the data or to import the data in Excel, the structure is the same. Only way that is different, it's like in the libraries that is going to help us, or the packages, sorry, that is going to help us to load that file, which will give us if it is a data, instead of putting, for example, me, I'm interested to run, I'm interested to load Excel file. I will put the variables that I'm going to give my dataset, because my dataset should have a big name, but I need the nickname. Where I need to use it, I will call that nickname. That is what we call the variable here. I put the variable because I want the data, and then equal, put read underscore Excel because I'm sure that my file has extension of Excel, and then I will go on my data where I have like my file explorer, where I search for the data set I'm interested that I'm interested to import. Then I right click, and then I can copy as a path. Then if I copy as path, I will come back on other programming, or come back on other programming, and then I will paste the code that is coming on this read underscore excel, and then paste this. So for us, we know that to tell this data that we are going to use backslash, we need to put this put it as double. That's why we need to put it as double here. So I can put it as double, put here as double, put here as double. Okay, and then after that I will run the code, so I'm sure that it is working. So if I run this, you see that it is working. But also to view the data set, as I mentioned, we'll use view from the previous. I use view and then put data, because my variable that I generate to represent my data set is called data. So if I run this, see that this is how my data looks like. And then let's come back to this. If you need this is not necessary for this at this part, but if you need to view the data, you see that we can use view as I mentioned. If we run this, you see that it is working now. To see the top 5 observation, let's say top 5 observation, we will use head open bracket, and then the variable that represent that data set, top 5 observation, or top few observation. Let's say that it will no longer be 5 by default, but by default will be 5. To see the above top 5 observation, I will use this. To see the top 5 observation, I will use this. That's only way. I will select this, I will see the top 5 observation. So this is how things also works. And also, if I need to see the last, I will use tail. Last 5 observation, I will use tail. So, and also if I need to know the number of rows, it is like number of observation. If we say number of rows in a matrix, because the data frame is in the form of column and rows. So if I need to perform to know the number of observation, because the observation is where we have rows, we will use n rows to know the number of observation. So if I need to know the number of variables, because the column represents the number of variable, the column represents the column represents the variables, I will use n columns to check for the number of variables that I have in dataset, which means that in the data frame, rows represent observation and also column represent the variable. That is only difference to number of observation also. And here I can check for number of column. This is only difference. If I run this, I will see. Let's run this, and then we will see what we see. You see that we can have 24 observation, and then we have 10 variables. This is how it looks like. And then from that we can view the name of variables by using names, and then open bracket and close bracket, and then put the name of data set. And then if I put the name of dataset, it's now the time for running, so that we can see. If I run this, you see that this is the the name of variables that my dataset has, country name, years, foreign direct investment, net inflow, net outflow, something like that, until to the 10 variables as Stata told me. So, sorry, as Ara told me. And then from that, I can do the data manipulation with a package which is called dprior. Dprior, it's like one of the packages that help us to perform the data manipulation. So from that, we can perform the data manipulation by using this code, which is called this command. So this package called dprior or tidyverse. It's one of the packages that can help us to do data manipulation. If we say the data manipulation, it's like taking data and then we make it to the way we want, either by adding variables, removing variables, deprecating, checking duplicate, removing missing variable. It's like formulating the data to the way we want. That's what we call the data manipulation. But it's simply we understand the data manipulation. It's like formulating the data to the way we want so that we can do the analysis based on the specific analysis that we are going to perform. This is simply what we call the data manipulation as also. So, and here deeper ROI as for data manipulation, we are going to use the data set that is bred in R so that we can do the data manipulation. The data set is called iris. So I call it as my data, and then to run it as that data, I will use as typo, and then if I run this, can get it. To view the basic, to see the summary statistic. This is to view the data set. If I view the data set, this is how it looks like. And then summary, it is used for summary statistics. Summary statistics in general for each variables. If I run summary and then I put the name of dataset, it can help me to see the summary statistic for each variables. You see how it now looks like. Sepal, I have sepal length, sepal width, I have cetacean species, sorry, two variables, petal length, petal width, their mean, quantile, first quantile, median, mean, such quantile, maximum, something like that. For each variables, depend on their data type, just by running summary statistic or summarize and then put the name of data to check for the. We can use class or structure to check for the data type. We can use class or structure to check for the data type. They will help me to describe the structure of variables, either it is numeric or categorical, the way they want to check for the name of here is for the name of variables that I have in my data. If I run name and then put the variable name or the dataset name, you see that they have sepal length, sepal width, petal length, petal width, and species. This is the only variables that I have in my data. And then the first element for data manipulation is what we call filter. A filter is like to select based on the specific variables that I'm interested. I want to filter my data only for, I want to see my data only for the species which is called the setosa. It's like a filter, it's like sorting, yeah. I select only dataset based on this. This is what we call filter. So I want to see my data if the species is equal to setosa only. So if I run this, let's run this. If we run this, if we run this, let's run this. If we run this and then we view our data, if we view my data again, my data, if I view my data, I will see the data only for setosa. See, it is for only setosa only. This is how Oh, I don't know the reason, but let's generate data one equal so that we can see data one equal, or to make it difference from existing one. If I view data one, as I mentioned, if I do data one, you see I will have Setosa only. See, I will have Setosa only because I select it as my data if the species is equal to Setosa. Here I can select randomly. Here it's like to select randomly the observation, 12 observation in my data. So if I run this only observation, if I do view, see how it works. This is how to select the specific, and then here I can select zip based on I can select, I can generate, or I can select based on the fraction. Here I can check distinct like can say distinct or non-duplicate, or duplicate. If I see distinct, go on my data and then look for distinct. It's like to check for duplicate. Distinct, put my data on the variable which is called sepal.rem, keep all is equal to true. The duplicate, it's like for checking the duplicate here. If I run this and then I will check for deprecated, to check for already deprecated variables or the deprecated values. You see that where I put true and false, where I have true, false, something like that, it means that there is no duplicate. But if we see the specific part where we have false, true, it means that this variable is deprecated. There is where we have it as more than one. But also if we check duplicate, there is no way to see that duplicate. And then from that we can see how we can arrange either by sorting the data descending or ascending. We do arrange and then put the name of data and then put comma, say if it is descending or ascending, and then put the variable that you want to arrange your data based on that. Maybe I want to sort my data on the variable which is called sepal.rem, but also by using sepal.rem. If I run this, you see that I will arrange my data. If I see my data again, underscore my data, but underscore, like to view the data set, to see how it looks like, to view the data set. I can view the data set to the way it is. You see, because petrorem from ascending the biggest to the lowest, you see from the biggest, I don't know, separate, I think, from the biggest to the lowest. This is how ascending also works. Rename, I can change the name of variables and then I rename it to the way I want. I can put the data because I need to generate a new data set which is called the data. Let's say it because say we need new data set where I'm going to rename the current existing variables to the way I want. I put rename and then open bracket, I put the name of dataset that I'm going to look for, and I put comma, I put the new variable that I want to put, the new variable that I want to assign for existing, to replace for the existing one. Because I want to say separate as a new, I put the new variables and then equal the old variables, comma, I can do, because you see here I do the name for two variables, that's why I can put this is one variables. I rename sepal as sepal new, and then I can put comma. I rename sepal.width as sepal_width, and I can add another variables until I succeed. So, but there is no need. If we do this, let's rename two variables, and then we will see how others can also do. If we do the names of the data set that we already renamed, if we do this, you see that our name has already changed. And then another thing which is important is what we call mutate. Mutate is like to create the new variables based on existing, but we also keep that variables. It's like adding a new variables based on existing. It's what we call mutate, and it is different from what we call transmutate. Transmutate means that I can generate new variables based on existing, but those variables that I use to generate new one, remove it. But also for mutate, if I generate the new variables based on existing, you keep both. Either those variables that I use to generate new variables, I will keep it in my data set, and then I will generate a new one. It means that when we use mutate, we want to add another variables based on existing. It means that for mutate, we add the number of variables or the number of column. But also if we use transmutate, it's like to reduce the number of variables. We keep the new variables that we generate. But also for mutate, both of them, either existing that helps me to generate new one, I will keep it, and then keep it that. So here, let's do it. We do data. Let's generate the data one because I have it above. Let's do the data 2 is equal to mutate, and then put the variable, the name of data set that I'm going to look for, and then I want to generate the new variable which is called sepal_Rwanda, which is called to the sepal new, to assign. And also I can perform a load because I want, this is a new one that I want. Always make sure that the name that we have it as a first, it's like a new variables that we need to generate, and it also put equal and then equalize by the old variables that we already have in the data set that we are going to look for. And then comma, I can put another variables that I want to generate based on existing, and then I can close bracket, then I run. If I run this, and then if we print the data, if we print, we no longer have data 1, let's have data 2. If I run this, see that how data also looks like. And then transmutate, if I generate new variable, only way I can put let's put data 2 here. I can generate the variable which is called Dusoza birth species, but based on species 1. If I generate this variable, because I use transmutate, they remove this variable that is already existing, because I replace this variable, I replace species Rwanda by Dusoza species. That is the only difference from that variables, as a difference between mutate and transmutate. And then the variables that is existing before. But let's see for mutate, all variables that I generate, so I'm sure that it is there. For mutate, let's see for mutate, see all variables, either for new one or existing one. But for transmutate, let's check before we run. So let's check. No, because we don't have it. Let's run this code and then we will see. So let's run this. We generate new. It's like replacing existing with new one. So if we do names and then can put the data to, see, you will see that the variable now is decreasing because it's like replacing, we remain with the variable that we generate only. Other than that, other variables, they remove it. In our data set, only those variables that we generate is what we remain for. Let's view the data too, and then we'll see. Yes, this is how transmitted works. It's like grouping those kind of things. So we are going to see how we can calculate or how we can perform summary statistics by grouping these kind of things. By grouping here, we are going to introduce new things which is called pipe. Pipe, it's like, as I mentioned, it's like a pipe, it's like a connection. So I want to go in Nyabugogo, and then, for example, someone can tell you that go in Nyabugogo and then find this. If you see this, go on this. If you do this, go on this. If you go on this and do this, something like that. Go here, and then if you find this, do this. After do this, come back to do this, something like that. So pipe, it's like a looping. I want to perform a specific task, but in way that it's like a process. This means that it's where we will use pipe. So pipe, to write a pipe, you can, the shortcut for write type, it's like Control Shift M. Control Shift M. It's like how we can add pipe in other programming. It's like pipe help us to perform a sequence of operations just in a single line, or in single code. For us here, we want to go, we tell the other that go on my data set, go on data set which is called my data set, and then group by species, look at each species. After look at each species, find the summary statistic by counting the numbers of each categories of species. After counting that, help me to calculate mean peto, and also help me to calculate mean sepal. This is how groups works, or how pipe works. But to use pipe, we need to run the package which is called tidyverse or dplyr, as I mentioned. If I run this, see what I see. Summary statistics like species, on species, variable which is species, we have Setosa, Venicora, and Vinisca. So it is 50-50, and then the average peto and mean peto or average sepal is this. This is how groups also works. And then this is how we can, this is another package that is important for us. We need to put in our mind. On the next video, we will see how we can continue to do the analysis, explanatory data analysis, just by using real data set. But I hope that you enjoy the course of today. But at least you have a basic on the other programming. But in the next video, we are going to focus on explanatory data analysis by going deep on the data manipulation, as I mentioned. So thank you so much for watching this video. You enjoyed the session. There is always room for improvement. So don't hesitate to write on comment where I can improve. We are here to learn. I know that I can learn from you, and also you can learn from me. There is always room for improvement. So thank you so much for watching this video.